Hey, Brady.
Hey, good morning.
Hey, Tom.
How's it going?
It's going all right.
Yeah, the how's the chicken thing? You had mentioned the chicken thing.
Oh,
Backyard backyard chicken?
did I mention my backyard chickens?
Yeah, yeah. Right after I mentioned my lawn, I had pretty well perfected my lawn.
Oh, yeah. So, yeah, my girlfriend wants chickens. Um, she has a particular breed in mind. They're called white Brahmins. They're very personable chickens. Um, they evidently are very good with people. They like being around people a lot, and they're good layers. So we applied for a backyard chicken permit, which is something that you have to have in the city of Liberty,
Mhm.
and um, you have to show, where the chickens are going to be located on your property and that they're not too close to other people's
Right, right,
residence
right.
buildings and things like that. So I don't know. A couple of weeks ago, I put in the permit and I didn't hear anything back, and then I finally just called the guy who's in charge of the permitting process, and he evidently hadn't gotten it. So I resent it and got the permit. So we now have a permit, and we are working on the coop because the chickens are supposed to arrive May 11th, supposedly. So
Oh, yeah, that's coming right up. Yeah. The
yeah.
so it's kind of like a health and welfare check to make sure your chickens are well cared for, or is it?
It's mainly about not pissing off the neighbors. I think
Oh,
um,
right. Okay. Yeah, 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 yeah.
you're not allowed to have roosters. You're not allowed to have guinea fowl because they're loud. And then you're supposed to keep your coop and your run at least um, 30 feet from the next nearest residence and 10 feet from all of your property lines. So, and
Interesting. Well, they've got this down to a maybe down to a science. Huh.
yeah, and so you have to submit a like blueprint, a plan of your coop that you're going to build and your run that you're going to build, and a layout
Interesting.
of your property lines and where it's going to be located.
Hmm.
Um, and then it's just one guy looking at your stuff and saying, yeah, that matches the requirements, and then they give you a permit.
Yeah.
And
Wow.
so
Yeah,
yeah.
cool.
Anyway, so I spent part of my weekend working on a chicken coop.
There you go. That's one for the record books, right?
So we're
Yeah.
we're in the process of building a chicken coop. And
Yeah. So
anyway, how
you're in
what
it for the eggs, right? Or are you in it for
I
the?
am in it. I am in it for the eggs.
Yeah.
My girlfriend is in it for the cuddly chickens, I think.
Okay.
And
So we're not
and
talking drumsticks here. We're talking.
no, 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 no. As a matter of fact, actually, the permit prohibits you raising the chickens for butchering.
Really? Ah,
Yeah, strangely enough.
okay.
So
Interesting. I bet
yeah.
it must get messy, I would assume. So they don't want that going on.
Oh my gosh, have you ever butchered a chicken?
I have not. I have not. I remember my grandmother telling me how she butchered chickens, and it was not a pretty sight.
Oh my God. So I was a young boy living in rural Texas, and I had seen my parents butcher chickens plenty of times. We had chickens. They were not cuddly chickens. They were laying and eating chickens. And sorry, for the rest of you, I'm going to regale Tom with a story about my first chicken butchering episode. Um, Forgive me. Um, so anyway, they sent me out to butcher the chicken because I had watched them butcher chickens plenty of times. So I took this chicken out of the chicken house. I took them to the stump where we typically did this. We lived out in the country, so we could just do this on a stump. And I had my little hatchet in my hand. I think I was about 6, and I put the chicken on the stump and I whacked the chicken's head off, and then immediately the chicken went wild in my hand, started flapping its wings, wrenched itself out of my grasp, and then flew down the hill. And
That's
so,
yeah, yeah.
so here's me, a little 6-year-old kid, running down the hill in Central Texas, chasing for about the length of a football field this headless chicken flying down the hill. And finally it ran out of steam, and I was able to retrieve it so that we could have dinner that night.
Holy cow. And
But
then
I had no idea that it was going to be that strong and actually just take off flying.
Yeah, yeah. Yeah, that's what my grandma said. She said, man, those rascals just run around and run around.
They run around like a chicken with their head cut off. Yes,
yeah,
exactly that.
Yeah.
At that point, I learned exactly what that phrase meant.
Yeah.
Anyway, how are the rest of you doing?
I'm pretty good.
Pretty good as well. Who was that? Who was the first person?
Me, Atos. And by the way, I killed my first chicken when I was 5 in Brazil.
Oh, okay. Oh, good. You've got a year up on me. Awesome. How about the rest of you?
Good.
You guys surviving at home?
Yep.
All right. Who are we missing? I don't see Karen. Who else are we missing? Chase is here. Connor. Addie Grace. All right. Well, let's go ahead and get started. I want to go over one last thing from linear regression, just to make sure that we finished that up cleanly. So let me share my screen here for a few minutes. So I have posted on the Moodle site this script. This script is a little different than some of the other scripts that I've put out there, because this script takes you through the slides that were in the PowerPoint where we went through regression. So there's some things in here that are going to be unnecessary for you, but they might be useful to you in terms of remembering what certain things are. So let me just get loaded up here. So this is the beetle data set. This is the beetles that are drying out because the experimenters subjected them to different levels of relative humidity, and then they measured the weight loss. When you run the model, so this is just a linear model looking at weight loss as it is influenced by relative humidity. The data file is the beetle data file. And when we run this, we can get the equation, which we've already looked at, which has the y-intercept of 8.7 and a slope value of -0.05. We talked about what R-square was in kind of conceptual terms, meaning that I showed you in the PowerPoint clusters of points that had different levels of R-square associated with them. And I explained that R-squared is basically a measure of how well the variability in the X data explains variability in the Y data. And so I want to call attention to that idea. So a common way in which people describe what R-square is basically just the amount of variation in Y that is explained by variation in X. And so one of the ways that you can think about this is when we think about an analysis of variance, we have a categorical variable that hopefully explains some variation in the data that we're seeing. And the residual variation is whatever variation is not explained by those categorical variables. in the same way, when we have a regression, we have a line, a linear regression has a line, and this line explains some of the variation in the data, but then there's also the residual variation, the distance that these points lie away from the line, that is unexplained by the linear relationship. And so in this way, ANOVA and regression are kind of the same. And so when we get an analysis of variance table, what we see is that we have sums of squares, and we calculated these sums of squares on this data set in the example. And what we see is we have a very large sums of squares due to regression, which is the relative humidity part. And then we have a little bit of unexplained variation that is due to the residual. And it's because the line of best fit fits the data really well, and that's why there's very little residual variation. So if you go back up to line 43, we can get the regression model. And so I've explained to you in the past what R-square is conceptually, but I haven't told you what R-square is in terms of calculation. R-square is simply the sums of squares of the regression divided by sum of squares total. So in this way, the calculation of R-square is precisely the amount of variation in Y that is explained, or the amount of total variation that is explained by the regression model. And so in this way, it really is the degree to which X is telling you about Y. So if we look in the ANOVA table here, we see that we have 23.514 and 0.616. Add those two things together, and that will give you the total sums of squares, which is 24.13. And the sum of squares regression is 23.514. And when you do that division, which is in this R script here, because you can do simple basic math in R, and we see that R square is 0.97447. And so this is R square value as we've calculated by looking at it in the ANOVA table. But if you go back up here and run summary model 1, you will see that it gives you the R square value, and the R square value is 0.9745, which happens to match exactly, with some rounding, what we calculated ourselves. So it's easy enough to calculate R square on your own if you have an ANOVA table that is generated from your regression model. And so there's nothing mysterious about it. And once again, as the cluster of points gets further and further away from the line, X is doing a poorer and poorer job of describing variation in the Y variable, and R square goes down. R square goes down as the amount of variation expressed as sums of squares due to the regression gets lower and lower, and the residual variation gets higher and higher. And there will come a point where the sums of squares due to regression get so low, and the sum of squares that is unexplained variation, the residual sums of squares, get so high that this thing will no longer be significant, and your R square value will have also plummeted to the point that the model doesn't really do a very good job of describing the relationship between X and Y. So I wanted to take you through what R square is in a little more rigorous way, so that you understand what R square is. When you are reporting the results of a regression, well, before we do that, do you have any questions about that idea? I realize we're now going back in time a little bit. Anybody have any questions about that? You guys are all still there, right?
Yep. Good. Good.
Okay. All right. Good enough. Whenever, I'm going to actually stop sharing my screen for a minute. So whenever you're reporting a regression, the things that you should report are the following. You should definitely give people the equation to the line. So in this case, it would be weight loss equals 8.7 minus 0.05 times relative humidity. Then after that, you would typically give somebody the statistical support for why you are saying that this is a significant regression. That generally involves giving people the F statistic from the ANOVA. Let me go back and remind myself of what this F statistic was. It was 267.2. And the F has in subscripts here the number of degrees of freedom, 1 degree of freedom for the regression model, and 7 error degrees of freedom because we had 9 observations total, which means we have 8 total degrees of freedom. And then the associated p-value that goes with this F value, which in this case is much lower than 0.0001. But then in addition to this, you would want to give them what the R-square value is, because this is another piece of information that helps somebody evaluate the value and validity of the regression. Is this a regression that actually explains quite a lot of the variation in the Y variable, or do you have a significant regression simply because you've killed the regression with a really large sample size? And in the PowerPoint, I gave you an example of where there was a really weak regression with a really shallow slope that explained almost none of the variation in the Y variable, but was highly significant because it was made up of over 336 data points. And so all of these things are useful to people knowing what the slope is. Well, this is a really shallow negative slope, but it's a really significant regression, but it's based on relatively few data points, which means that those data points are probably pretty tightly correlated to whatever the X variable is, because the R-square value is very high. And so this summary information is useful for anybody who knows anything about regression, of kind of evaluating whether or not your claims hold any water about that regression. Questions about that? All right, then I want to move on. This next thing that we're going to be doing is multiple regression. And I want to introduce you to the ideas of multiple regression, but we're actually not going to perform a multiple regression. And a couple of reasons why. You could take an entire course in regression analysis if you ever go to graduate school and are interested in this kind of thing. Multiple regression is also much more complicated to calculate. Multiple regression is the point in the semester where we would move from doing hand calculations to doing everything on computer, because it actually involves matrix algebra. When I was in graduate school, I had to take a course in linear algebra. Linear algebra is a field of math where you basically do with matrix manipulations, adding, subtracting, multiplying, and dividing matrices from one another. And the entire reason that I was required to take linear algebra was because of regression analysis and multivariate stats. So what I want to do is I want to introduce you to the ideas behind multiple regression. We'll work through an example on Wednesday that is an example from your book, so that you're aware of what it does and you're aware of, at least in concept, how it works, so that you kind of have some awareness of it. But we're not actually going to do any homework assignments, no problem sets, no write-ups or anything with multiple regression. So just at this point, you can kind of just sit back and relax and think to yourself, okay, I'm not going to have to utilize this. But while you're sitting back and relaxing, don't get so relaxed that you stop paying attention. So regression, multiple regression. It's simply used when you have a response variable that may be responding to multiple independent variables. So the two examples that your textbook spends a lot of time on are an example where they have plant cover, biomass, and primary productivity. These are all things having to do with plant communities, and they're interested in how these things affect the relative abundance of different kinds of plants. So in biology, you have C3 plants and C4 plants. They do photosynthesis differently. C3 plants tend to like cool, moist environments, and C4 plants tend to like hot, dry environments. And so they're interested in saying, okay, to what degree do different aspects of the plant community influence what kinds of plants might be there? Another example is from this experiment down in South America, where they have these forest patches that have been left behind after the rainforest has been cleared for agriculture. And there's a data set in your book that we'll look at actually on Wednesday, looking at how the abundance of birds and the diversity of birds in these forest fragments is affected by how big the fragment is, how many years it's been since that patch was isolated from primary forest, the distance to the next nearest patch, the distance to the nearest larger patch, an index of stock grazing history, and the altitude of the patch. And so in this case, we're looking at how are two aspects of bird diversity affected by all of these other kinds of things that might affect it. Other types of questions that I just made up over the weekend. How is the amount of your stimulus check that goes into savings affected by your debt burden, your employment status, the number of children you have, et cetera, et cetera? If you are an economist and you are interested in, for example, whether or not the stimulus money that is coming to all Americans right now is going to be spent to support local businesses and things like this, or whether it's just going to be socked into savings, you could build a model that would basically explain how much of the stimulus check goes into savings based on any set of factors that might influence that. Here at William Jewell College, we have an admissions office that works on recruiting students to Jewell. One of the things that they might be interested in is what influences the probability that a student is going to come to William Jewell College, or any college for that matter. Well, it might be determined by the price of the college per year, the number of contacts by admissions counselors, the number of campus visits, geographic distance from the college. You know, all of these things might influence that response variable of what's the probability of going to college X. And as an admissions team, you might want to know what those factors are. If it really has everything to do with cost of the college and the distance from the college that the person lives, then there's not really a lot that the admissions office can do about that. But if the number of contacts by admissions counselors, campus visits, et cetera, if that also plays into things, then an admissions office would say, okay, well, this is where we need to be putting our money, because these activities of ours are highly correlated with what our response variable is that we are interested in. And so multiple regression has a lot of real practical value outside of the field of science, where you have these experiments with categorical variables that you're looking to see how those categorical variables influence variation in whatever your response variable is. So you'll see people using multiple regression a lot. So there's a data set that I deal with my biology students periodically. And when we think about Darwin's finches, so in the Galapagos Islands, there are these finches. They're famous in evolutionary biology because presumably competition for food has led to a diversification of finch species based on how they partition food resources. And so they have been studied a lot, so we have a lot of data about them. And one of the things that people look at is the morphology of the beak. What shape is the beak? And the shape of a beak is determined by its length, its width, and its depth. And so we can actually look at those things and look to see if those variables are correlated with one another. And so I have prepared another R script that is also on the Moodle site from today. But I'm going to do this simply because it's going to be easier to do it this way. So can you guys see my R window?
Yeah.
Yeah.
Okay, cool. So this is a data set from a guy named Andrew Hendry, who works on Galapagos finches in the Galapagos. And it's basically just a bunch of morphological measurements on finches from 2 sites in the Galapagos Islands, taken back in the early to mid 2000s. And we have beak length, we have beak depth, and we have beak width. And we also have various aspects of head length and head width and head depth. And so these are all morphological characters of the head. And as a result, you might expect them to all be highly correlated with one another. Now, unfortunately, over the weekend, I went to run this in preparation for today. And the package that I used to use to make 3D scatter plots no longer functions, evidently. And it functioned last semester, and evidently some changes were made with a new update of R. And so over the weekend, I had to go and figure out another way to make 3-dimensional plots. So I'm going to use a package called Plotly, which you can install on your own computers, and you can run this thing that I'm about to do. And so one of the things that you can do is you can make more complicated figures than what we've made so far. And so what Plotly is going to be doing is basically I'm just going to save a figure called Fig. I'm going to make it in Plotly. I'm going to define that X is the beak length, Y is the beak depth, and Z is the beak width. I'm going to ask it to make a 3D scatter plot with markers with a certain opacity and a certain size. So these last couple of things are just formatting descriptions. And when I do that, it gives me a 3-dimensional scatter plot. Ah, there it is. And in this case, it gives me just the X and the Y and the Z. And if I look up here, I can tell what X and Y and Z is, but I can also just have it put labels on those things. So this next set of script is adding labels to it. So now we can keep track of the figure. And so here we have a figure that is beak width on the Z-axis, beak depth, and beak length. And the cool thing about this is with your mouse, you can, if your mouse has a scroll wheel on it, you can use the scroll wheel to zoom in on the data, or you can use it to zoom out on the data. And the other thing that you can do is this is an interactive 3-dimensional plot. So you can grab it and you can move it around. So for example, if we want to look at the relationship between beak length and beak width, let's turn it this way actually, so that birds with small beaks are here and large beaks are here. Birds with narrow beaks are here and wide beaks are here. You can see that there's a positive correlation between beak length and beak width.
Hey, Paul.
Yeah.
at that, right at that position, can you hit export and get that snapshot and then twist it, get another side view and hit export and get the side view?
I do not know. I have not tried that before, but it looks like we can. Or can we? Well, we'll see. It's only going to allow us to save it as an image. So let's see. That's a good question, not a question that I had thought about. So let's see. Nope, that just gives us the, yeah, it's not going to do that. So if we turn it and click export and save it again, yeah, it's going to give us the same image over
Okay,
and over
so you just
again.
have to take a straight screenshot.
Probably just have to take a screenshot of it.
Okay, okay.
Yeah, they're the same view. That's unfortunate. And there may be a way of doing it, but since I have all of like 24 hours of experience with Plotly,
Sure.
it may be not a limitation of the program as much as a limitation of my own experience with the program. So anyway, you can look at beak length versus beak width. You could look at beak depth versus beak width. Once again, beak depth going from small beaks to larger beaks, and narrower to wider beaks. The cool thing about it is that this grid, it tells you where you are in three-dimensional space. And so what you see with this figure is that actually these three variables are all collinear. They're all correlated with one another, such that you go from the lower left-hand side of this box to the upper right-hand corner of this three-dimensional box. And this is exactly the kind of data that multiple regression is designed to look at. It's going to look and see to what degree is beak length and beak depth correlated with beak width, if you wanted to look at that. And so we could actually look at beak length and see the degree to which beak depth and beak width are correlated or not with beak length. These three things all go into making up the shape of the beak of a bird, but this is basically what it's doing. And we'll run these two lines of code in a few minutes, but I want to go through a little more of the PowerPoint before we get there. So one of the cool things about this is that this would be the equation of the line. The y variable, which is the dependent variable, is determined by x variable 1, x variable 2, x variable 3, and each of these things has a slope value associated with it. And so to find out what y is, you would multiply the slope of the first coefficient times the value of the variable. Slope of the second coefficient times that variable, the slope of the third coefficient times that variable, and then there's some error that is unexplained. This is the residual variation. These betas, these slope values, are what we call partial correlation coefficients. And it's the correlation between y and, in this case, x1, assuming that all of the other variables are held constant. Beta 2 would be the relationship between y and x2 holding x1 and x3 constant. Beta 3 is the correlation between y and x3 holding x1 and x2 constant. So these are what we call partial correlation coefficients because they are reducing the variability, the relationship between y and x1 to just that relationship, ignoring all of the other variables that are in your data set. So your book stated it best by saying it allows us to measure the relationship between the dependent variable and any independent variable, adjusting for the remaining independent variables. And what that means is that when you run a regression, which we will now go and do, it doesn't matter what order you put these variables in here. You can run it with beak depth first and beak width second. And when you run this, what it will give you is it will give you the y-intercept it will give you the slope value for beak depth, which is 0.64274. It will give you the slope value for beak width, which is 0.06493. You see that one of these is much more highly correlated than the other one is, and the one that has the higher correlation is also the one that is statistically significant. So this is basically saying that beak depth is a much better predictor or determiner of beak length than beak width is in this case. The R-square value is 0.7764. That would be the, if you ran, well, let's just do that. If you ran the analysis of variance on this Gatto ANOVA table, the sums of squares of beak depth and beak width, if you added those two things together and then divided that by the total sums of squares, that would give you it would give you 0.7764 in theory, because the regression now is due to beak depth and beak width, and then there's a relatively high degree of unexplained variation in the residual sums of squares. And so when you see R-square of 0.7764, it's because there's relatively high residual sum of squares compared to the total sums of squares. So what it's basically telling you, though, is that beak depth is a significant predictor of beak length, but beak width is less so. And the intercept is not equal to 0. So anytime you see the intercept here, once again, it's testing to see if the y-intercept is 0. So we did that with beak depth and beak width. But you could also change the order of the variables, and it shouldn't make a difference. It shouldn't make a difference if it's actually giving you partial correlation coefficients, and I'll explain that in a minute. And so once again, here we see that beak width is 0.06493, and beak depth is 0.64274, and the p-values are all the same. Now, there are other versions of multiple regression where you can order the variables, and the model will run such that it asks, to what degree does the first variable that you have in your model explain variation in the y variable? And then once that variation is accounted for, it asks, okay, of the residual variation left over, how much of this residual variation left over does the second variable explain? And it will continue to go through those until you've exhausted all of your independent variables that you think might be important. This is known as stepwise regression. And when you do stepwise regression, changing the order of the variables does change the results. Because if you enter variable x1 into the analysis first, and it explains a lot of the variation, then there's very little residual variation left behind to be explained by variable 2, variable 3, variable 4. If, on the other hand, you put variable 3 in there first, and it doesn't do a very good job of explaining variation, there's a lot of residual variation left over to be explained by these other things, but a portion of it has already been explained by this variable that is not very well correlated with the response variable. So normally what you would want to do is you would want to do a regression that will give you these partial correlation coefficients so that you can actually look and see how is the y variable being influenced by the x variable independent of variation in the other x variables. But there are applications where you would want to do a different type of regression. And like I said, once again, this is more of a whole semester course in regression to delve into this. But what this results in ultimately is, in the same way that you can have an equation like this for the weight loss beetle data, you can also have an equation for finch beaks, where beak length is determined by the y-intercept, which is 3.96, plus beak width times 0.064 0.064, sorry, plus beak depth, now I've not left myself enough room, times 0.643. And this is the equation of the line. So if you know what the depth of a bird's beak is and what the width of a bird's beak is, you should be able to then make a pretty reasonable prediction of what the length of that bird's beak will be. But the thing that is influencing this primarily is the relationship between depth and length. It's this relationship right here, not the relationship between width and length, which there is also a relationship there, but it's not as strong as the relationship between length and depth. And you see how tightly that is in this axis.
Hey, Paul, do you see that in the slope? Is that what we're looking for? We're looking for
Yes.
a steeper
Yep.
slope.
Yeah.
10
Yeah.
times.
So you see that this slope is relatively steep. This slope is really shallow. That's why this slope ends up being the one that is significant, and this slope ends up being the one that is not.
Okay.
And once again, the thing that you can look at over all these things also is you also pay attention to the X and Y axes, the axes. Some of these have more variation associated with them than others do. And so always be thinking about these things in terms of variance, because all of these things are always going to be dealing with how much variation is there in the data. If you have a lot of variation along the beak length axis, then you're looking for then also a lot of variation along the other axes of variation, beak depth and beak width. If one of these has reduced variation, then chances are it's not going to be tightly correlated, simply because there's less variation to spread across whatever the other variable is. And so it's always a good idea to think about all of this stuff in terms of total variation. So anyway, the code is there, the script is there in the Moodle site. You can make your own three-dimensional rotating scatter plot if you want. What we're going to do on Wednesday actually is we're going to look in your textbook. So you should probably read this between now and then. The example that is in box 6.2 in your textbook on page 115. We're going to work through that in R on Wednesday and see if we can't recreate the same analysis that they've presented in your textbook to look at what is actually a much more complicated and real world sort of data set than this one that is here.
What page was that on?
This is, it starts on page 115 is box 6.2, but they talk about these two models, these two data sets from the beginning of chapter 6 through the first part of the chapter here.
Okay, thank you.
But yeah, it's box 6.2 on page 115, 116. So multiple regression has all of the same kinds of assumptions that we have experienced before. It requires normality of the data, but in this case, the data are multivariately normal. And so rather than having a single dimension that is a hump that looks like a normal curve, there's actually a multi-dimensional mountain of normality that rises up out of this plane if you have three variables. And so and if you start getting into more than 3 variables, it becomes difficult to think about. You get clouds of normality that look like eggs floating in space. I just happen to have an ostrich egg sitting on my desk. So you can test multivariate normality. There are methods for testing multivariate normality. There's a non-constant variance test that can be done in multiple regression as well. So all of the assumptions that you have for a simple linear regression also apply to multiple regression. It's just the methods for doing those things becomes more complicated because you're now dealing with multi-dimensional data, and that always brings with it its own set of headaches. One of the other problems that your book talks about is whenever you have X variables that are highly correlated with one another, it gives you a false sense of sample size in a sense. And so you have to worry about what's known as multicollinearity, when you have a bunch of predictor variables that are all correlated with one another and also correlated with whatever your predicted variable is. And so generally what you have to do is you have to reduce that number of variables in a way that maintains that variation, but also removes the fact that they're all correlated with one another. But we're not going to worry too much about that at this point. We're going to just play around with it a little bit on Wednesday and see how it works and how it can be used. Questions? All right, I am working on a problem set for linear regression for you that I will hopefully have out to you later on today. And I will also post at the same time the report later on today. And with that, I'll have due dates. I haven't chosen the due dates yet, but I'll probably give you about a week to work on the problem set, and then another 4 or 5 days after that to work on the write-up. And then the last thing that we're going to do, I'm going to talk to you a little bit more about multiple regression on Wednesday. And then after that, we're going to start on analysis of covariance, and that's the last thing that we will do. And there will be no problem set on analysis of covariance, but there will be a write-up on analysis of covariance. So that will be due finals week, and we're staring down the end of the semester, which you should hopefully all be glad about.
I'm excited. It's just freaky that we're already done, you know?
It does feel weird because I don't know. It's like it feels like it's creeping up on me. I don't know how you guys feel. Some housekeeping things. Have you guys logged on to Moodle and checked your grades?
Yes.
Okay. Do those grades comport with what you think you had in the class?
I honestly thought I had less, but yeah, not good though.
Okay. All right. So nothing unexpected in there. The grades that I've handed back to you, rather than sticking grades on your papers, I've just basically been saying, okay, as I evaluate your paper, here's what I've got, and then I'm just plunking those grades into the grade book on Moodle. On your write-ups, look at the comments that I've made on your write-ups, because on your next write-up, you need to, be fixing those things that need fixed. None of your write-ups were like so terribly horrible that I'm like, oh my gosh, I can't believe you turned this thing in. One of the things that I also have noticed is that at least for probably about half of you, the way in which you wrote about your results in the first write-up was different than the way you wrote about your results in the second write-up. And it indicates to me, and it was a good change, it indicates to me that you're getting more and more comfortable with the language of talking about data than I actually expected you to. So I was actually happy to see that shift from the first write-up to the second write-up. It probably helps a little bit that you were continuing to talk about the same data set. So on Wednesday, what I will do at the beginning of class is I'll actually go through the report assignment and give you a little more context for the data that you're going to be analyzing in that, so that you can continue to work on how it is that you write about the data analysis that you're doing. So that is all I have for you today. Anybody
Okay.
have any questions? Yeah.
Yeah. So for my grade on Moodle, it looks like it has like the percentage for my grade, like what my
Yes.
grade is, but then it's divided by 475.
Oh,
So
yeah,
like
that's,
now I
yeah.
have like a 19% in the class.
I have no idea why it's doing that. So it really divides it by, is there a section on Moodle where it just gives you like your percentage?
Well, it has, so the columns are like grade, range, and then percentage, and then letter grade. And in grade, it has like what I think is my real grade in the class.
Yes,
And then
that is
range is
what
like, yeah, and then range is 475. And
that's
it's
the total
dividing
number of
my
points.
grade by the range.
Yeah, and I don't use Moodle for assigning grades, so it's
Okay.
doing some weird thing. You have 475 points so far that have accrued in the class, but your average is whatever that grade is that I've calculated. And so when I go to assign your final grade, I actually have all of this in a spreadsheet on my computer. When I go to assign your final grade, it's whatever your average is. So if you want to just check the math, add up all of the points that you gained across all of your assignments and divide by 475, and that's what gives you that percentage. So if it's 80%, you know, if you're at 80%, you have a B minus. Don't take that 80% and then divide it by 475 again. That's a glitch within Moodle. Yep.
Okay. Yeah, I just saw that it was like 19% was my grade.
Yeah, and
overall.
yeah, and I think
X at the top.
Grace emailed me last week and she's like, so it looks like I have this percentage, but then the letter grade is an F. Like, why is that? I'm like, it's because Moodle is stupid. So yeah, we'll just work off for your percentage score because that's how I always do grades.
Okay, thanks.
All right. All right. Enjoy a little bit of respite from problem sets and things like that, and I'll get things out to you later on today.
All right. Thank you.
Hey, thanks,
Thank
Paul.
you.
All right.
Thank you.
Bye.